So here is hopefully is the answer to your question. Number 7 wants me to find the impulse. Now impulse is another word for change in momentum. And there's two ways to find it. I can either go mass times change in velocity, which is mv final minus mv initial, or I can find the impulse by going force times the change in time. There are two ways to find impulse. Now looking at number 8, the fact that they gave me the time and they want me to find the force, I think down here in number 8, I'm going to end up going the force equals the impulse, my answer from number 7, divided by the change in time. In other words, number 8, it's going to be divided by 2.1 times 10 to the negative 3, and what's going to go right here is my answer from question number 7. How can I then get question number 7? Well, I'm pretty sure I'm going to use this version here. So we have the change in momentum is going to be mass v final minus mass v initial. Now, I'm not going to actually figure out how much momentum the pile gets. Instead, I'm going to figure out the change in momentum on the hammer, because whatever momentum the hammer loses or gains, it's going to transfer to the pile anyways. So I'm going to look at the hammer. That's also why it says the magnitude of the impulse, because if I tried to calculate direction, this would get confusing. You know what? I'm going to focus on the change momentum of the hammer, because if the hammer loses momentum, the pile gains momentum, and it's going to be the same amount. So what's the mass of the hammer? The mass of the hammer is, oh, I can do one more thing, by the way. I think the initial momentum of the hammer, because the initial velocity of the hammer is 0, I think I can ignore that, because it allows it to drop. Okay? So really, I just got to find mass times v final. Well, the mass is pretty easy. It's 900. What I don't know is v final. What I don't know is that. And that's really what I'm going to spend most of my time finding. Well, I know v initial is 0. I know the height, or the distance, is negative 3.5 meters. Why negative? Because we're ending up below from where we started. And I know the acceleration is negative 9.8 meters per second squared, because we're releasing the hammer and letting it fall down in free fall. That's how a pile driver works. It lets gravity create the force. So I think I can go Vf squared equals Vi squared plus 2AD, and then how to get rid of a squared? Square root. I'll get the square root of 0 squared plus 2 times negative 9.8 times negative 3.5. And if I crunch the numbers, I get 0 squared, I'm going to ignore. 2 times negative 9.8 times negative 3.5 square root. I get 8.28. And if I multiply 8.28 times 900, I get that answer, which is 7.46 kilo newtons seconds. 7,454 newton seconds, or kilogram meters per second, because those are the same units for momentum. So the answer to number 7 is C. What did I get? 7,454. 7,454. And you can either write that as newton seconds, or you can write that as kilogram meters per second. Those two units are pretty interchangeable. Then I'm now going to transfer this down to there. So and if I then go this number here divided by 2.1 times 10 to the negative 3, I get 300 and, well, in scientific notation, it's going to be 4, because it's 3.5, times 10 to the 1, 2, 3, 4, 5, 6. 4 times 10 to the 6th. And they want me to write it in this format here. They want the value of b. So I would argue the value of b is 4. Now, that's if I use all of the answers without doing any rounding off. If you round off along the way, you might get, well, I don't know if you'd get 3.4. I think you'd still be okay. So, there's my solution. Hope that helps. Oh, and there's my phone ringing. Perfect timing.